Hello students, this is our max class. In the previous class we have seen coordinate geometry up to exercise 5.4. Today in this video we are going to learn new chapter, that is chapter 2, numbers and sequences. Let us see the heading sequence. A sequence, the name itself indicates it is an arrangement or it is an order. That is, a sequence is an arrangement of a number in a particular order. And here, when we arrange a number, we follow some method or rule. For example, let us say that here we have 1, 2, 3, 4, 5 shown up to some infinite value. Now this one we can call as a sequence because difference between any two numbers or same. That's why only we call this a sequence. See here, 1. If I add 1 for the first number, I get 2. Then again I will add 1 for the second number, I get 3. Then again I add 1 for the third number, I get 4. So difference between of this number has plus 1. Difference between of this number has plus 1. That's why only we call this number as a sequence. The rule is that here each number plus 1 is adding. Similarly, the next example 2, 4, 6, 8, 10. Here difference between any two number we have plus 2. That is, I add plus 2 for this first number, I get 4. So difference between these two number has plus 2. 6, 8. 8 minus 6 also plus 2. Then 10 minus 8 also plus 2. So the rule is that here each number plus 2 is adding. This is nothing but a sequence. Not only adding, we can subtract, multiply or dividing any value. So that sequence is an arrangement of numbers in definite order according to some rule. Here the rule means we can add, sub, multiply or divide. Next heading, terms. The various numbers occurring in a sequence. That means terms indicates the each number A1, A2, A3 shown up to AN, which means first term indicates A1, second term indicates A2, third term indicates A3, then AN indicates nth term of the sequence. Subscript. Next heading, subscript, the position of the term, which means the place of the term. This is the subscript. So A1 indicates the first term, 2 indicates the second term, 3 indicates the third term, n indicates the nth term. Next heading, general term or nth term. The number at the nth position of the sequence is an. That is, last term we call as a nth term. Now we move on to the next heading, finite sequence. A sequence containing finite number of terms, that is, for example, some odd numbers less than 10, that is 1, 3, 5, 7, 9. then means it has a ending number 9. So it is called a finite sequence. Next heading we see infinite sequence. A sequence of successive terms which not ends. A sequence of successive terms which not ends. That is 2, 4, 6, 8, 10 and so on. And so on. Shown up to infinitely. In this sequence has no end term. So only we call this infinite sequence. We move on to the next heading, Fibonacci sequence of numbers which has no visible pattern. That means the arrangement of number is not following any pattern. Just we take two numbers and based on that two numbers we find the next value. That is known as a Fibonacci sequence. For example, see the first term A1 is equal to A2 is equal to 1, which means first term and second term has 1. Then third term A3 is equal to A1 plus A2. That is, third term is equal to adding first term and second term. That is 1 plus 1 we get 2. Then fourth term A3 is equal to adding second term and third term. That is 1 plus 2 we get 3. Then fifth term A5 is equal to adding A3 plus A4. Then we get 2 plus 3, 5. Then sixth term 3 plus 5, 8. Like that going on. So, the general term of this sequence, Fibonacci sequence is an is equal to an minus 2 plus an minus 1, n greater than 2. That means A3 is equal to 3 minus 2, 1, 3 minus 1, 2. Therefore, A3 is equal to A1 plus A2. Therefore, the sequence is 1, 1, then 1, 1 add means we get 2, then 1 plus 2 adding 1 plus 2 we get 3, then 2 plus 3 we get 5, 3 plus 5 we get 8, 5 plus 8 we get 13, like that going on. The next heading, sequence as a function. Sequence can be recorded as a function whose domain is the set of natural numbers or subset of natural number 1, 2, 3 up to 4. Function notation A of n for an. For better understanding, watch this video. Afterwards, we see some examples of first exercise.
Is simply a set of numbers in a particular order, or a set of numbers which follow a pattern. The most basic example of a sequence is that of counting numbers. 1, 2, 3, 4 and so on. The numbers follow an increasing pattern. The 3 dots mean the list goes on forever and are referred to as the ellipses. The numbers don't necessarily have to be continuous to be a sequence. A list like 0, 5, 10, 15 and so on are also said to be in a sequence. What's the pattern here? Every number is increased by 5 to get the next number. A constant increment of 5. Let's take an example of a sequence which has an increment of 2, like 1, 3, 5, 7, 9 and so on. For your exams, there are just 2 things you need to know about any sequence. First, how do you find the nth term of a sequence? And second, how do you define the sequence? What do I mean when I say the nth term? Say I ask you the 31st term of the sequence. You have no time to write all the 31 terms to find that out. We need to have a formula, and yes, we have one. It is the first term plus n minus 1 times d. ft is the first term, n is the term number. So if we want to find the 31st term, we just substitute 31 in place of n. And d is called the difference between any two continuous terms. It's called the common difference. It's extremely simple to derive this formula, but you don't really need to know it for your exams. So don't dwell too much over it. In this example, as the first term is 1 and the common difference is 2, the nth term will be 1 plus n minus 1 times 2. How do we define a particular sequence? We just solve this further. Expanding this gives us 2n minus 2 and we add the 1. This gives us 2n minus 1. Here, n takes the value of all natural numbers. Don't forget, n is the term number. If we call this sequence S, the first term of the sequence will be written as S1. To find the first term, all we do is substitute 1 in place of n. We get 2 times 1 minus 1. And 2 minus 1 gives us 1. Now with this formula, try finding the 9th and the 21st term of the sequence. The 9th term will be 2 times 9 minus 1, which equals 17. And the 21st term will be 2 times 21 minus 1, which equals 41. 41 is the 21st term of the sequence. So to define the sequence, we just use the nth term formula and substitute the values of the first term and the common difference.
Let us move on to the examples. Example 2.19. See the question. Find the next three terms of the sequence. Given that 1 by 2, 1 by 6, 1 by 10, 1 by 14 shown up to infinite. Here 4 terms are given. We have to find the next 3 term, that is 5th term, 6th term and 7th term. Let us do the solution. First you take down and write the given sequence, that is 1 by 2, 1 by 6, 1 by 10, 1 by 14 and so on. Here you have to observe numerator has the same, that is 1, 1, 1, like that going on. Then next you have to see the denominator. So in the first term denominator is 2, the next term denominator is 6, then third term denominator is 10, then fourth term denominator is 14. Then you have to observe, if I add 4, we get 6. Then if I add 4 from the second term, we get third term. If I add from the third term, we get, if I add 4 from the third term, we get 14. 10 plus 4, 14. So, you have to write in the above sequence, the numerator or same, and the denominator is increased by 4. So, the next 3 terms are that is A5 is equal to 1 by 14 plus 4 is equal to 1 by 18. Then A6, that is sixth term, 1 by 18 plus 4 is equal to 1 by 22. Then seventh term, A7 is equal to 1 by 22 plus 4 is equal to 1 by 26. Therefore, the next three terms are 1 by 18, 1 by 22, 1 by 26. This is the answer for this question. Let us move on to the second subdivision. Here the given sequence is 5, 2, minus 1, minus 4 shown up to infinite. Here also we have to find the next three terms. Let us do the solution. First you take down and write the given sequence, that is 5, 2, minus 1, minus 4 and so on. In this sequence you have to observe first term 5 and second term 2, which means the sequence is decreasing. So, if I add minus 3, to first term, I get 2. Then 2 minus 3, I get minus 1. Then 1 minus 1 minus 3, I get minus 4. Therefore, you have to write here each term is decreased by 3. So, the next three terms are A5 is equal to minus 4 minus 3, we get minus 7. Then A6 is equal to minus 7 minus 3 is equal to minus 10. A7 is equal to minus 10 minus 3 is equal to minus 13. Therefore, the sequence is 5, 2, minus 1, minus 4, minus 7, minus 10, minus 13. This is the answer for this question. Now, we move on to the third subdivision. See the question 1, 0.1, 0.01 shown up to infinite. In this question also we have to find next three terms. First you take down and write the given sequence 1, 0.1, 0.01 and so on. Here you have to observe 1 divided by 0.1. You have to observe the difference. Here also you have to observe the difference. 1 divided by 10 we get 0.1. Then 0.1 divided by again 0.1 divided by 10 we get 0.01. Therefore, here each term is divided by 10, hence the next three terms are A4 is equal to 0.01 by 10 means we get 0.001. Just you move the point to the left side. Divided by 10, we have only 1 0. So just you move the decimal point left side. Just you move the decimal point 1 digit from right to left. That is 0.001. A5 is equal to 0.001 divided by 10 is equal to 0.0001. Then sixth term, A6 is equal to 0.0001 by 10 is equal to 0.00001. Hence, the sequence is 1, 0.1, 0.01, 0.001, 0.001, 0.0001, Hence, this is the answer for this question. Students, today homework exercise 2.4 first sum related to the above examples. It has 3 subdivision. Do it properly. Thank you.